a secure network.
Okay. I mean, my question is in generic, what is a network? Why do we need network?
Oh, sorry. So that we're able to communicate with each other, basically. Maybe that's too simple.
Yeah, I think simple is fine. Yeah, you don't need to overcomplicate if not needed. Yeah, so I think yeah, that's a good answer. So a network is a way that, simple as the word sound, network. You bring the communication, you enable the communication between different devices. And that could be as simple as like two computers connected to each other to as big as how I am connecting with all of you. It is happening through a worldwide wave network, right? And this is how all the communication happens right now in the world. So, but what is special about network in Docker? What is special about network in Docker? Come on, anyone? I think Nika, you already answered kind of.
Um, from what I remember, I know that it can be secure. I know that you can do it with many containers,
Mm-hmm.
and it's isolated.
Mm-hmm. Okay. Okay. Um,
All of the pieces of the network are contained in the Docker. That's the isolation that Nika mentioned, but you also have all of the environments, um, programs, databases, all basically the containers in the network can contain everything, but it's isolated instead of being on a physical on-prem network. If I'm probably saying that badly, but
no, I think yeah, that's right. So, so why do we need to talk about network in Docker especially? Is because the way how Docker has been designed. Docker has been designed to isolate the whole environment, the container environment, completely from the system itself. Okay? That essentially means that you are separating the processes, you are separating user management, you are also separating the network. Because if you have the same network, then you cannot actually leverage all of the features of Docker. Okay? And then it will not be a containerized environment at all. Because network is very important part of the whole any running system. Okay? So essentially in Docker, the way it has been designed that the host machine has its own networking. Okay. So you have a network card which manages this. Okay. And Docker has its own network, not only network, but the DNS as well. Okay. So the whole communication happens within the container. Okay. But many of the time, you need to have multiple containers communicate to each other. Okay. Getting the point? For example, you are running a front-end application. Okay. Front-end needs to go to back-end to fetch the data, right? And where will this data come from? This data will come through some APIs, right? But problem is your front-end is another container, your back-end is another container. And these networks are isolated. They are not connected to each other, right? So how would you enable a communication between them, right? So that is the challenge that Docker network helps you to solve. Getting the point? Those who are comfortable, please open your camera. Those who are comfortable, okay, so that I can see and kind of see some reactions. Yeah. So that is the whole purpose of Docker network. Okay. Now essentially there are three types of network in Docker. Okay. And I am not sure. And ideally, I would be actually going ahead and talking about new lesson, but I believe that it is important to do a quick recap. So I'm going to do a quick recap right now. And I wanted to talk to you about, give me a second. Here. No problem. Those who are comfortable, that is fine otherwise. Can you see some diagram here, everyone?
Yes.
Thank you. Okay. So what I was saying is that, give me just a second. Yeah, this network, this diagram. Okay. So this diagram essentially talks about three types of network that you have in Docker. Okay. The first one is the host network. That is the first one that you're seeing. Okay. This host network will always remain there. Okay. Whether you have a container or not, whether you have VMs, the network always exists. Okay. In this network, what you can see essentially is that there are multiple containers. Okay. So this is the host machine, the outer layer that you are seeing. Okay. Then inside you have the containers. Okay. So in this case, what happens is that this is Docker 0. Okay. This is kind of a network. Okay. Where multiple containers are getting connected. Okay. So this is called, the first one is the bridge network. Okay. This is the default network. So all containers, when they start, okay, they by default become part of this network. Okay. Bridge network, the default network. Otherwise, you can create your own network as well. And you can ask the containers to join that particular network. Okay. So, and all the containers who join the network, they all will get different IP addresses. Okay. So for example, this one, this is, let's say, container number 1. When it has joined, it got the IP address 1702. This container got 1705, right? So this is how the containers get the IP addresses. This container also has an IP address, okay? But this is the private IP. This is the local IP within the container. So nothing out of a different container can directly reach out, okay? So this is the default network, okay? The bridge network. Another network is the host network. Docker also gives you option where you can connect directly the networking of the container with the machine itself. So if you start a container, the port number of the container becomes the port number of the machine. Okay. So they directly use that. We will see that when we are doing example. Okay. And third one, yeah, this one, host. Yeah, you can see. So container network becomes a host network. For that, you have to specify when you're running Docker run, Docker minus network is equal to host. Okay. And the third one is called Docker network is equal to none. Here, container will not have any network access at all. Okay. Even all the containers running, okay, in the same runtime, even they cannot access it. It is completely detached from the network. Okay. So this is a very short overview of Docker networking. Okay. So whenever you are doubtful, always go for bridge network. But let's say you are not able to get it running at all. You can use Docker network is equal to host and get your application working for the very least. Okay. So this is a quick recap of network. Okay. Once you do some hands-on, you will probably understand more. Okay. Meanwhile, let me know if you have any question.
I guess I do have a question since we went over it last Thursday. But what is the main difference again? If you can explain in your words between bridge and overlay.
Oh, okay. See, so thing is that this bridge, these three are different types of network. Okay. But this types of networks are actually enabled by different types of drivers. Okay. So overlay is actually a bridge only. It is enabled by different plugins. Okay, different drivers. So in Ubuntu systems, you have overlay 2. Okay, that is the driver which runs this. So this is the overlay 2. Somewhere you have overlay only. Okay. So these are just the different network drivers. That is like comparing apple to orange. Okay. Types of network is different thing, and plugins or drivers are different thing. Okay. So you can probably go here, Docker network drivers. You can search about it and you will see different types of drivers here. Okay. So, okay. Oh, and your question was about this particular. Okay. So I will come to that. Okay. So let me show, I should have a diagram somewhere. Okay. So these are different types of network I talked about. Okay. And out of this, there are some more drivers. Okay. Which enable us to run containers in multi host environment. Okay. So one of that is called MacVLAN. Okay. This is the driver which helps you to connect containers running in different EC2 servers completely. Right now, what happens is everything which is running on the same machine, they can actually communicate. Okay. But this one, like overlay, MacVLAN, they help you to connect with different drivers in different EC2 servers. Okay. So Jens, I think you were right in your question. With overlay, should be some mention of overlay 2 here as well. Oh, overlay 2. Yeah. Okay. Anyway, I think I will find the diagram and send it to you. I will send a table I have with the comparison. For now, what you can understand is that these are different types of drivers, okay, which enable networking in Docker, which will help you to connect with different containers on the same machine, on the same EC2 server, EC2 or your machine. Host will help you to directly map the IP address of the machine with your container. Overlay will help you to communicate with Docker containers running across different types of nodes. Okay. And this one IPVLAN I haven't used. I believe it is used for IPv6 communication as the way it sounds, but I haven't used this. MacVLAN also I have not used, but this is also used to have containers running over different types of network. Okay. So for example, you have an EC2 server on this network, another server is in a completely different network. They can communicate with each other using MacVLAN. Okay. None we already talked about, that is no network. Okay. Yams, did it answer your question?
Yes, thank you.
Yeah. So let me show you this Docker overlay. Okay. Yeah. So I think probably this diagram should explain more. So this is your host number 1. This is your host number 2. Okay. Here what happens is you have a container. It can connect with another container on the same host only. Here you will have another container that will connect within the same host. But using this network overlay, you can actually connect this container to entirely different host machine that is here. Okay. Okay, this is now Kubernetes thing. So let's not talk about this. Yeah, so probably just remember this diagram. This will probably help you understand. Okay. Now the thing is, we don't stress a lot on these networks. You may think that why don't we learn overlay? Why don't we learn MacVLAN and all? Because Normally, we orchestrate Docker with Kubernetes nowadays. Okay. So the networking part, communication in production is taken care by Kubernetes. Okay. So Kubernetes has its own methodology of networking that is called service. Okay. So we will learn about service and we will learn about probably ingress as well in content when we are learning Kubernetes. Okay. All right. Yeah. But yeah, that's a very good question. Yes. Yeah. We also don't teach this nowadays because we mostly touch on Kubernetes nowadays. So we only talk about these 3 types of network which are used in Docker containers. Okay. Any other question? All right. So with this knowledge, so today my voice is a bit, I have got a throat sore. So my voice is a bit uh, damped. I hope you are still able to hear me. But I will be slightly less louder and slightly slower. Okay.
I can hear you just fine, and I hope your voice feels better
Okay.
too.
Yeah, I'm just taking warm water as well with me. So,
No,
all right. Okay. So that was a quick recap of network. Okay. In the same way, you have volumes. I believe you have learned about volumes, anonymous volume, bind mounts, okay, for creating volumes. So they will be useful in the lessons as well. Okay, so be very attentive on these lessons. Docker and Kubernetes are the most important chapters in whole DevOps. Okay, in the last class, I had requested everyone don't miss any assignment. In the last class, I made everyone do every assignment. Okay, almost everyone who was in the class finished all the assignment with me. Okay, I will try to do the same for today, that everyone finishes all the assignment. Okay, see, you learn more by assignment rather than just watching some code and commands and anything. Okay, so everyone please work on the assignments. All right, so in today's lesson we are going to talk about Dockerfile. Okay, so I believe this lesson has not been taught, correct? Based on what I'm seeing in the list, this lesson will be taught today. Correct, everyone?
correct.
Okay. All right. Any questions before I continue talking about Dockerfile? All right. Okay. So let's talk about Dockerfile. Okay. So what we have seen so far. Okay. So please go to this lesson. Okay. And yeah, let me send you this. This is the link. Okay. We are taking the first lesson on Dockerfile. Okay. So we have seen so far that we use images. Okay. We have seen images of MySQL. We have used images based on Ubuntu, based on Python. But did you ever think how these images are made? Okay. These images also have come from somewhere, right? So the way how this Docker works is it has a concept of Dockerfile. Okay. Dockerfile is a text file, okay, which contains all the instructions that you give to Docker to build your image. Okay. So this is how a normal Docker file looks like. Okay. And as you can see, it has certain instructions. Okay. Some of these instructions are for documentation purpose. Some of them actually perform the actions. So for example, this one. First one that you see is from Python 3.9. Okay. What does that mean is we are going to use the base image Python 3.9. Okay. So like this, you have multiple instructions in a Docker file. So let's talk about each of these instructions one by one. Okay. So this is the page, everyone. So we will try to demystify all of this. This is very important, very, very important. Okay. To be able to write your Docker file. Okay. So the first instruction that you see, okay, so it serves as a blueprint. Okay. What does that blueprint mean? This means that, let's say, you want to cook a recipe. Okay. So what is a recipe? I mean, let's say you talk in food. Okay. If you want to cook certain food, let's say you want to cook, let's say, uh, sandwich, or maybe you want to make tea, or you want to make probably paratha. Okay. Whatever you want to cook, it has certain instructions given, right? You first take the instruction, do that thing. So for example, let's say you want to make probably sandwich, right? So the bread becomes the base. You take the bread, then probably you take the slice of cheese, you put it on the bread, and let's say, okay, you put it in oven or whatever machine you have, and you put it for a certain time, right? So these all are set of instructions that you follow. Okay. It may have some ingredients. So for example, you want to make a tea, you take water, you take tea leaves, you boil it, you take the extracts, you mix the milk, you mix maybe sugar, whatever. You follow the instructions. The way how you cook that, Dockerfile is also that. You follow the instructions and then finally you cook the image. And that cook the image that you have cooked, that is the image you can upload in Docker Hub, which you can use to run your containers. Okay. And this is built on like the open source platform. So anyone who gets access to your recipe can create the same taste, same flavor of the tea, same flavor of the image. Make sense? So let's talk about the instructions that we give. So the first instruction is from. This will tell you what type of image you want to build based on which base image. Okay. So for example, you want to, let's say you go to Subway, you select the base, right? The bread. You can select multi-grain, you can select Italian grains, or you can select whatever you want, right? That is the base. Similarly, here the base is the main operating system or the image with the libraries that you select to run your images. Okay. You will not understand it till you don't do it. Okay. So don't worry if you do not understand right now. Okay. People confuse a lot in selecting the base image. Okay. Which base image should I select? Okay. We will talk about it once you practice more. Okay. So normally the rule of thumb is select the best possible base image depending on which libraries, depending on which OS you want to run your application on. Okay. Second is maintainer. Okay. Maintainer instruction is used to specify who is writing this Docker file. Okay. This has nothing to do with image, just for documentation. Okay. Then you have run. Run is just the commands. Okay. That you use to run the instructions. So any command that you give here after run, Docker will just run that command. Okay. So for example, if you run probably a cp command, it will just go ahead and run cp for you. Okay. If you go ahead and do, let's say, pip-install, it will install the dependencies for you. Make sense, everyone? This is the run command. Then you have copy command. Okay. Copy command will copy the file from your machine inside the container. Okay. So what does that mean? That means that the application code is on your machine, right? not in the container. But for the application to run, code should go inside the container, correct? So you use copy command to copy the code, any file from your machine inside the container. Okay, we will understand. Add is also same, but it will just copy the URL. Okay, file from the URL inside the given path. Okay, so this one is copying app.py file inside app directory. Okay, another one, okay, is called the expose. Okay, so what is expose? Do you remember we talked about ports? You write -p 8080:80. There you are telling which port your application will run on. Okay, we did this one when we were using Nginx, correct? So that is the purpose of this. You tell which port your application will run on. Okay, any question so far? Okay, fine. And finally you have CMD. Okay, this is command, short form of command. This is just a default command to run whenever the container starts. Okay, this is very similar to run. This will also run the command. This will also run the command. Okay, what is the difference? Difference is this is for any purpose. Any command you want to run, you use, you run. This is the default command. This is the command which is run at the end. Okay, normally you will use only one CMD. Okay, and that should be the final command you want to use to run your application. Okay, for example, when you run your Python code, how do you run it? Python file name, right? So that command becomes your final CMD command. Okay, let's say you are using Java, right? So you will use, okay, Java -v and whatever the command you use to run the jar file or the var file. Okay, so that is the CMD command. I know you will not understand lot till you do not use this in practical. Okay, so let's use this in practical now. Okay, so let's do but before that, let's do a quick recap. For example, this is a sample Docker file. Okay, what does it say? It is saying that we want to use Python based image I want to use. Okay, where will this come from? It will come from Docker Hub. So if I go here, if I search for Python, you can see Python is there. Then you can see 3.9 version. You see, we have 3.9 version here. Okay, so it will use the 3.9 version here. You see this version? This is the 3.9 version. Okay, we call it tag here. This is the maintainer. Okay, one of this which was not mentioned is work directory. This tells which directory I want to work. So all of the command or instructions will run in that path only. Very, very important. Okay. Then you have copy requirements.txt. So here what happens? It will copy the file from your machine inside the container. Then you are running pip install. Okay. Then you are copying the file again. You are running expose. I want to run my code on port 8080. And you give finally the command app.py. Make sense, everyone?
Yes.
I do have another question.
Mhm.
It's just this came up when Edwin was teaching last time, but the from keyword on the very top, Is that how VS Code defines that it's a Docker file?
No.
When you make a new file in VS Code, how does VS Code know that it's a Docker file and not just a regular file? I found that strange.
Okay. See, so as such, I believe that there is a default convention that you always name a Docker file with name capital D Docker file. Okay. And when someone defines a file in that way, Docker always, the VS Code has been made in such a way that if there is any file with name capital D Docker file, it will recognize that as Docker file. Okay. Just like Terraform. If you have any file and you end with .tf, it will automatically convert it to TF file, correct? But that makes no difference in the nature of the file, by the way. Okay. Whether you name it Docker file, whatever name you give to it, Docker has no effect on that. Okay. So how VS Code treats, whether it changes the color or not, it has no effect. Oh, okay. For example, I could show you this. So let's say that, let's do this one. Okay. So this is the directory I want to work. Okay. Now the moment I go here and I define a file, okay, let's say I define main.tf. Where does this color come from? This is coming from the plugin that I have. Okay. If I define something as mark.md, where does this icon come from? VS Code has been designed in such a way, right? If I define a file, Docker file, it automatically detects it is a Docker. Okay. So YAMS, it has nothing to do with the name as such, the nature of the file. Only thing is, if there is Docker mentioned in this, VS Code has been designed that it knows that it is a Docker file. Okay.
Okay, so even if you rename that, but it's still it's still the syntax inside the file is Docker syntax. It would still run if you specify, hey, I want to run this
100%.
file. Okay, thank you.
In fact, let's do that. Yeah. So see, even if I write from and all, it does not detect. So what you had assumed earlier doesn't work, right? Okay. All right. So let's do some examples, everyone. Open your computer, everyone, and let's copy the first one. Okay. And create a file named Docker file. This is the convention. You always name the file as capital D Docker file, but not mandatory. So I will show you even without this, it works. Okay. Please paste this. And let's build this image. I'm making sure I remove everything. Let me remove these images. Okay. So you can see I have no images right now. Okay. So let's build the first image, everyone. And think I'm just organizing my files. Okay. So this is the hello world Docker file I have. Okay. How do you build an image? The command is docker build -t, and you give the image name and the tag name. Okay. So you can write docker build -t. Okay. And you can write whatever image name you want to give. Okay. So here it is giving image name as HW. You can give anything. 0. If you do this, it will docker build. Oh yeah, dot. Okay. Don't forget to give dot. Dot says my Docker file is in this directory. What you can see it is doing is it is pulling the base image. You do Docker images. You see, I got the image here. Did everyone see? This is the image I created just now. Let's run this. How do we run? Docker run. Okay. Docker run, and you give the image name. You see, it is printing hello world. Did everyone get this? So what does this Docker file do? Using this Docker file, we have used Debian as the base image. And we are running this command echo hello world. Very simple. Okay. You can see this one is named Docker file. Okay. Let's say I create an image, okay, with a different name than Docker file. Okay. So I don't have Docker file anymore. I give it a name, Chandra Docker, whatever. Okay. You see, it does not know it is a Docker file anymore. You are not following the convention, but that is fine. It will still work. How do you do? So you will write docker ps -a. Let me remove this one. Let me remove this one as well. Okay, I have removed everything. Now you will run the same command, docker build -t. Okay, let us give it a name, my docker. Any name you can give. Only thing is now you will write -f, okay, and the docker file name. Yeah, dot. Okay, Yems, did you get this?
Okay, I see. The .f is if, like you said, it's not convention, but if you have it named as Dockerfile with a capital D, it by default finds something called Dockerfile.
Exactly. If you have not followed that convention, you have to specify that with -f. Now you can run the image again. You can see Docker images. I can run Docker run. Okay. See, hello world. Okay. So that is a very difficult way of printing hello world. You could use simple Python print, but you are using Dockerfile, Docker build, Docker images, Docker run. But you got the hello world at least in Docker now. Let's do the next one. In the next one, what we are going to do is we will run our game Dojo Jump using our own images. Okay, everyone? This is very important. Everyone will follow with me. Everyone will follow with me. Everyone ready? Give me a thumbs up. Okay, cool. What we are going to do now is, okay, we will write git clone. I will get the code base. Okay. Now, this is the code I got, right? This is how a code will normally look like to you. You are given a code base. You will be given task that, okay, Dockerize it and run it. Okay. This is a very beautiful and typical example I always give while teaching Docker. Now inside the place where your main code base is, create a file with name Dockerfile. Okay. Now tell me how to write this Docker file. What should be the base image, everyone?
You start with from,
Okay, cool.
and then we pull what image do we want to pull from Docker? Would we still use Ubuntu latest?
I would like to see your judgment. What do you think? What should be the ideal way of doing it? See, if we install Ubuntu, we can use Ubuntu, right? We can use Ubuntu. We can write Ubuntu latest. Fine. But bare metal, the bare operating system Ubuntu does not have Nginx installed. Correct? So this code needs Nginx actually. Everyone agrees on this? Do you need Python here? You don't need Python, correct? You need Ubuntu. But with Ubuntu, you need Nginx as well. So we could do this and we can actually write this, right? We can write apt update. We can do all of this. Apt install. We can do this. But if we have an Nginx image already, why don't we directly use that? You see, we already have Nginx image. So we can directly use it. Okay, you can see this is very popular. 1 billion plus installs. Okay, so let's use this from Nginx. Let's use the latest version, right? If you want to use latest, you don't have to mention. By default, it is always latest. Okay, what next?
Is the maintainer, is that optional?
It is optional, yeah.
Okay.
It is just for documentation. Like who's maintaining this?
Then I suppose we would do, if we skip maintainer, then we would do, is it work directory?
Oh yeah, yeah. I think yeah. We can use work dir. Yeah. What should be the working directory, by the way?
Would we just call it app, or would we call it maybe Doja Jump?
Okay, we can do that. Okay. So let's create Dojo Jam. Okay, what else? We got the Nginx installed. We created a folder, Dojo Jam.
We have to copy requirements, don't we? Or install
Yeah, we don't have the
requirements.
requirement here, but yeah, you need the
Oh,
code to actually run, right? And how do you
right.
copy code?
You
We
would
have
run.
C, right? Run is to run the instructions.
Yeah, so we have to
Oh,
copy the files first, and then we can run the
and then we run it.
requirements.txt.
Right.
Okay.
So we will copy index.html where?
From here, so dot, or would we specify index.html?
It will by default go to the index.html file path if you don't specify. Or
Okay.
I think let's make it simpler. Yeah. Okay. So normally what happens if you do not specify it, it will by default go with the same name. If you specify, it will just get changed. Something like this. So if you are not changing, generally recommendation is to not give a new name. Okay. What else do we need? We need to copy CSS as well, correct?
Correct, and also the
Awesome.
main.js.
Yes, and main.js as well. And then what?
So is the shortcut, instead of doing them one by one like this, just to do copy dot and then space dot?
You can do that, but thing is that do you need this zip file inside server? You don't need.
Okay.
So sometimes you can skip it if you don't need. Ideal approach is you don't put anything unnecessary inside the container. Because think about this. You have one image. You see size of one image. This image is 453 MB. You know what is the size of Elasticsearch? 1.5 gigs. Think about that. You put unnecessary files. Even one file is, let's say, 100 MB. You are running 10 instances of it. You have 1 gigs of extra storage being consumed. And system will become probably slower keeping track of extra file. So no unnecessary thing. But sometimes we will do copy in future, but for now, let's make an ideal one. Next what? Which port Nginx will run? Everyone.
Expose. So
Those
is this the
80.
8080?
expose 80, correct? So it will tell that we want to run on port 80. Again, it is only for documentation. No real effect. Even if you write 8080, no real effect. It will still run on port 80. It is only for documentation. So if someone looks at your Docker file, they will know I need to look at port 80.
Okay, that's interesting. So even if we accidentally put a random port, you could fool someone else.
Yeah, but never do that, because the person who is using it, they will get confused. This guy is opening port 8080, but there is nothing running on port 8080. Do you think it will run? What is your opinion?
No, we still need the run command or
Oh, you
command.
still have to build it and then run it?
Okay, yeah, we need to build and we need to probably run command. But why do we need run command here? Do we do run
Well-
Linux?
Oh,
Port binding.
Port binding, yeah, but that will not happen in Dockerfile. That will happen outside. If you look at the path, you are missing one important thing here.
hmm. Oh, did we?
The work
mm,
directory.
The path where you are putting the files. See, this will Nginx serve from this path? Which path Nginx serves from? USR, share.
Oh, we didn't go down far enough, is what you're saying.
So if you want to serve your HTML file, you have to put the file in this path. Getting the point, everyone? So if you put your file random, it will not work. So you have two options. Either you put here, otherwise you directly put it here. You don't use it. For now, let's keep it very, very simple code. We will directly put it inside the directory.
So just to clarify, if we're not giving it the direct path, it's like it doesn't know where to go, basically.
Actually,
Okay, okay. And it seems like it would be shorter to just put it in the first place instead of having to copy it 3 times, I guess. But I don't know.
we could actually just write copy dot and this, it will work, but your image will just become larger. We will be doing this. In fact, no one follows all the standard practices, but let's do the standard. Okay, let's try to do those. Okay. Okay. So what is the command to build this? Docker
Build -t
And then you name it.
name
give it name.
colon.
Let's
On version.
yes.
Yeah.
Do I need to give -f?
No, because it's a Docker file.
Exactly.
But you do put a dot.
Exactly. Why?
Directory, like
Because
saying
it's in that directory.
Exactly. Which directory your Docker file is in? It is in the current directory. Okay. You see, it is pulling the Nginx image. You see, it is pulling all the layers. And see, it is running copy command. First command, second command, third. Exporting image, saving image. See, 15 seconds ago, we built an image, 193 megabytes. Sounds good? Any question? Let's run this. How do I run it?
Docker run and then the image ID hash.
Okay. My name then?
Let's see.
Do we need to
Then
go?
would you just put the image hash then?
Oh, okay. Image hash can be good, but let's give the name that is better. Name and tag. Are we missing anything here?
The port?
Yes, 100%. You need to tell which port it will map to. Which port you want to map?
Oh, so this would be, is this 80:80?
We can do 80:80. Yeah. What is first 80 and what is second 80?
The first 80 is,
The machine port. Okay.
okay, the
And
machine port. So that would be our port. And then the second 80 is the container's port that we're exposing.
port 80. Okay. If I give 8080, it will run on port 8080. Make sense, everyone? So let's do that. Okay, so container has started. Which port should I look for? 8080 or 80?
80.
Think again. Port 80 or 8080?
Interesting, because if this is the machine's port, then shouldn't this be 8080?
Okay, let's go with the people who said port 80.
Let's go.
Yay.
It's whatever you made it, so 80.
It was coming from cache.
You can't refresh?
No. You see?
Because it was localhost, right?
Exactly. So it should be actually port 8080 because this is the machine port we binded, right? See, don't change your concept because you see something wrong. Everyone thought, oh no, you just told it should run on machine. Probably I was wrong. It runs on the container port. Okay. And this is where it will, even if you refresh, it will run. Okay.
Quick question, Chandra, on 80, as we're binding it in the Docker file, is that because the Dojo jump files and the Nginx has 80 specified?
No, it is because Nginx runs on port 80.
Oh, it defaults to port 80, Nginx.
Even if you remove it, it has no effect. Even if you give here, has no effect. It is for documentation. You want to try? Let's try this. Docker ps -a. Okay, here you have Docker build -t. Okay, Dojo 9876. Let's just give this a name. 0. Not. It took very less time this time. Why? Can someone tell me?
Is it because it already knows the path?
No,
Because it's already grabbed Nginx.
exactly, because
Oh, okay.
Nginx is already here. This is all directly
Mhm.
from this one.
And it looks like some resources were cached.
Exactly. This is what it's saying, right? Many of the things are already cached, actually.
Okay, that's what you meant, Tristan, by it's already grabbed it.
Yes.
I meant like the image itself. Like if you try to create an image file with Ubuntu and it's the first time it's going to go online and grab that. And then the second time you run it, it doesn't need to like go and find it because you already have it.
Okay.
That's a good point. Thanks, Tristan.
Exactly. Okay. And yeah. So we got this one. Okay. Now we write Docker run. Okay. Minus name. Dojo 9876 minus P. Let's give it on port 8080 colon 9876. Okay. Colon 1.0. It will show it has started running. But if you open your port 8080 now, it will not run. Reason is not being served on port 9876.
So if you had a different, if you weren't using Nginx, but you had a different image underneath,
Yeah,
the default might not be 80 at that time. It might be something else.
yeah. For example, let's say I want to use MySQL. It will be then 3306.
Yeah. Okay, thank you.
Okay.
If we're doing Nginx, since it defaults to 80, would we want by preference just for the port binding for 80:80, just so that we don't have to specify localhost and then port?
If I understand your question correctly, your question is about choosing which port to use here.
Yeah, our machine's port.
Normally, recommendation is that you use the same port which is inside to outside, but some exceptions like you should not use port 80 on your local machine because port 80 is considered a privileged port, so you should not use port 80. So normally recommendation is to use any port between 6000 to 9000. Okay, best is use in 8000 to 9000.
Okay, thank you. And just 8080 is just an easy port to remember.
Yeah. You see, they're like port 8080. Only there are a lot of memes on port 8080. If you go, I think, yeah, there are a lot of memes on port 8080. And port, there is a guy with number plate port 8080. Port 8080. Number plate. I think there was a guy who can be famous. I think it is giving local results. That's five. But there was a guy who got his. There's a guy with number plate as Docker. I don't know why. I don't know how to Google search. Number Docker, number plate. How do I search for this? So there's a guy who has gotten this car with plate name as Docker. Someone has gotten Python. So yeah, they're like people. And the person who created, I think there is at least from Python, I think. I know the guy. I don't know why it doesn't show. Yeah. But there's a guy who created this Python. He has gotten this car number plate with Python. Yeah. But yeah, overall thing is that this port matters. Normally avoid using any port below 5,000, below actually 3,000. 3,000 also people use. All right, so that was a quick lesson on using this. Did everyone get this running Dojo Jump on the machine? So this was the first Docker file that you have written, everyone. Okay. Let's Dockerize a Flask application. Okay.
Can you go just a little slower with the steps?
Oh yeah, sure. Yeah.
Okay, thank you.
Yeah. No worries. So we have done this one. I believe everyone did this. And let me see if it is time for break. Is it time for break? Oh yeah, I think we are over an hour. Yeah, so it's almost time for break. Over and time for break. Yeah. So let's go for 10 minutes break. Okay. Returning, we will Dockerize a Flask application. Okay. See you in 10. All right. If everyone is here, we can start. All right. Okay. So let's do a quick demo on Flask application. Okay. Okay. And in fact, let's do one more thing. Yeah, I do want to teach this one. Okay. So as you have seen here, okay, what is the image we built? Okay. So Docker PS, Docker RM, Docker PS minus AQ, nothing else. Docker images, Docker RM, RMI. I am removing these images, okay, which I don't need. Yeah. So if you remember, this is the first image we built 25 minutes ago. Okay, everyone. Now I want to show you the magic of type of images. What we have used right now is the latest image. If you don't mention, it is latest image. I will show you something with Alpine. Everything is same. Okay. We are just using Alpine image. We did talk about it, I believe. Let's use that now. Okay. So I will again do Docker build. Okay. Minus T. I will write Dojo Alpine. Okay. And dot. Okay. What is the difference? I have changed the base image from latest to Alpine. Okay. Now you can see this is a different image. So it is pulling from Docker Hub. Okay. So you can see we have built the image. Now there is very interesting thing that you will see here. Docker images. Do you compare the image size?
Yeah, it's a lot smaller.
Lot smaller. And what is the difference we did? Only thing is we changed it to Alpine. Nothing else. Code is same. This will work exactly same. Okay. It will work in the exactly same manner. No difference. The difference is the image size. And why does it come? Because we have chosen the image to be different. So whenever you are putting anything in production, try to make the image as smallest possible without compromising the functionality as well. All right. Any questions?
Well, yeah, can you go into some other slimming options? So here you're choosing Nginx Alpine to slim the image. What other options are there to slim something down?
So there is something called slim. You just simply use slim. Okay. So the different types is latest has everything. Okay. All the libraries, most of the libraries, most of the files, most of the tools like VI editor, nano editor. Alpine has nothing. Alpine does not even have apt. Everything is removed in Alpine. So it is very small. Slim has apt. So you can install dependencies on Slim. Okay. But Slim doesn't have the unnecessary file. So biggest is latest or buster. Smaller is Slim. Even smaller is Alpine. Alpine the always the smallest. What are different options? So you can see here, so there are different options. One of that is Alpine. There is something called mainline. Mainline is probably the very large, okay? There is stable. Here the libraries are very stable libraries, okay? There is something called bookworm. I don't remember what is bookworm. What is bookworm? Okay. Yeah, you can see here, okay? It is very small. JC has apt. Debian has long-term support. Buster has what you need, but always newer. There's a bullseye. Everything you need but newer. Bookworm is the newest version of Debian. You can probably read more about Bookworm. And then Ubuntu is like the Ubuntu best. Okay. Alpine is for this. JC and Stretch are for Debian versions. Yeah. The Debian and JC and Stretch we generally don't use. I don't know what is Bookworm for. It seems Bookworm is just the latest version. Okay. I think probably this blog has a lot of information on this. Yeah. This is Alpine, smallest. Debian we already talked. Bookworm is just like it uses Debian 12, it seems. Yeah, that's all. Slim is like significantly small. Okay. Yeah, you can see the difference here. Bookworm is so large, and you can see the Alpine. So small. 20 times as small. All right.
Thank you.
Right. So now let's go ahead and do it for Flask. Flask. Okay. So in this directory, I will create a file with name DevOps Dockerfile. Okay. So actually, okay, this is the file I have created. Welcome to DevOps. Okay. It is running on port 80. You can change it to anything. Okay. Now let's create the Docker file for it. What do you think? How should we write the Docker file for it? Come on, everyone. Let's write a Docker file for it.
This one does need Python to run, so we do want Ubuntu.
Okay. All right. So I think instead of this will be too difficult. So let's use VS Code only. Yeah. So let's create a Docker file and let's write from, okay, and Ubuntu base image. Then what do we need to do? We need to install updates, right? Like run apt get update. Okay. It will install the updates. Then we need to install Python, right? Apt get install Python 3 -y so that it automatically does it. Then we'll do apt install, apt get install. We will need Python pip, right? So we'll install pip as well. Okay. What else do we need? So we got the base image Ubuntu. We install the Python. Then this is a Flask code, right? So we'll need Flask as well. So we can now run We've installed pip, so we can write pip3, install fast. What else? We can set the working directory, correct?
Yes.
So we can write work dir. Where do you want to put it?
If we just put dot, is there anything wrong with that, or just, yeah, just slash? Is that
Not recommended, because dot will be on the root path. So you should not put your application in the root path.
okay? So
Let's create a probably fast. Okay. This is the place I'm putting my code. Or we can write application. Probably this is where all the application code is. Okay. Okay. So directory has been created. What do we need to do? We need to copy the file, right? This code should go inside this to run, correct? So we can write copy. Okay. And
the name of the code that we want to copy.
name of the code. Yeah. Okay. So we can write this. And what do we need to give here?
And since we put the working directory, we can just put dot.
Exactly. You can just put dot. Okay, cool. Sounds good. What else? We now need to run the command, correct?
Yes, and it's in the form of an array.
Yes. And this should be okay. We have talked about this earlier, right? What is CMD? It is the final command which runs on the container. So we'll write Python. Okay. And we can give the file name. Okay. How does this look to you?
I guess we can, for documentation, we can expose port.
100%. What port do you want to run? Here, you decide the port, right? It is not that Nginx where port is defined. You decide the port. So if you give port 8080, you write port 8080. Okay? Because you can run on any port, correct? What do you think?
You had a typo in line 4 on your Docker file.
Oh.
Python.
Oh, yeah. Thank you. It would have not worked otherwise. Thank you. All right. So let's give it a try. So we will write Docker build -t. Okay. Write py flask. Okay. Colon 1.0 and dot. Given double quote is not mandatory, by the way. Okay, so you can see it is running apt update. Everyone, please follow with me as well. I want to make sure this works, but I'm still sending you this. You can see it is still running updates.
So we created a work directory called, we haven't created it yet, but we annotated a work directory called application. Do we need to Do we need to create that before we build this or no?
I think what the work directory does is it actually does build it when it runs this Docker file inside your container.
Exactly.
Okay, cool.
If it is not there, it will create. If it is there, it will just change that. Okay, this is the path I have to work now. Okay, so we are running apt install. Okay, now pip is installing.
Can you just scroll back to the build command for this one?
Yeah. Okay.
Okay, thank
Oh, yeah. See, you can see it has taken over 2 minutes already. Over 2 minutes. That is too slow. What do you think? What did we do wrong? It should not take so much time.
We used Ubuntu and Ubuntu is fat.
We used Ubuntu latest, which itself is heavy. It has no packages. True. What could we do otherwise? Better way?
Is there an Alpine version for Ubuntu?
There is. We could use Alpine, but Alpine doesn't have apt.
And, we can't install anything else right after that.
There is a way you can use APK. APK is the way to install in that, but generally not used a lot.
Is there one with just Python? Could we use like Python or something?
Exactly.
Oh, Flask, right?
Or Flask?
Exactly. We can directly use the Python. Right. We are wasting our time doing this because we could write a different Docker file and which could directly use the Python 3. And if it is Python already, we don't have to update, we don't have to install, we don't have to install pip. What do you think?
I think that's probably better, especially since this is taking so much time.
Exactly. So it will keep running, but it will run. Okay. It will work as well. So what we can probably do is we can use this time to create another Docker file. Okay. Docker file pyalpine. Okay. Yeah. Let's write the Docker file for this, guys. Yeah. What should I write? From
This is just a guess from not looking at the documentation, but can we do from Python 3?
100%. So let's look for Python 3. Okay. It is actually everything is Python 3 nowadays. So it is only Python 3. Then we can look for Alpine actually. So there are so many Alpine. Let's go with the most simple one. So actually you can just write Python 3 Alpine. Okay. So what we can do is we can write Python. Okay. 3 Alpine. Okay. That's it. We got everything. All of this is here now. Next.
So all we need to do is still run to install Flask.
Yes, we need to do. So pip install Flask. Okay. Pip is installed. What else?
Other than this, all the rest of the commands should be the same.
Exactly. So we can actually do this. We can copy and yeah, So 9 line becomes 6 lines. Code will run in port 8080. So it will remain 8080. We'll copy the file inside and run Python 3. Yeah. Actually, it will be Python only because we're directly using Python. Okay, let's see what is happening to this. Oh, it failed. So something happened to it, okay? It seems it could not install pip or something. Okay, if you wish to install a non-Debian managed Python package, create a virtual environment. Okay, so it is asking us to use this VNV, pip, VNV. But anyway, I think let's directly use this one. Okay. So we could write Docker. I think we could directly use this one. We could just give -f Dockerfile find dot. And you can see how fast it is. No update, only pip install. Boom. Image is built. Right? But if you compare that time with this, it had taken over 5 minutes already, by the way. It has still failed. Somewhere it failed. We could debug, but yeah. So
Can you walk the logic back on why this is faster? I just wasn't quite following.
yeah, sure. Yeah. So if you see this command, this one is using basic OS, installing updates, installing Python, installing pip. Here what we did, we directly use Python as the base image. So no need to install Python, no need to update, no need to install pip. You directly do pip install run Python Flask. Make sense?
So within Docker, you are running Python now in this manner,
Yes.
totally skipping Ubuntu.
Yes, because we can directly use Python.
Okay.
Okay, yeah. So let's see the image we built. This is the image we built right now, right? Right, Docker run. And it's nice me. Okay. Let's write hello Flask. Okay. We need to bind the port 8080 colon 8080 image colon 1.0. Okay, let's see this. Yeah, it shows it runs. Localhost. Yeah. How beautiful it is. You don't have to do any installation, anything. As simple as use the base image, get the code, install dependencies, run it. What is the image size? 75 MB. Super small.
And we saw the second use of Alpine here. So is that kind of a term that is universal, meaning bare
Right.
bones?
Alpine always means bare bones. I mean, nothing. As small as possible.
Oh, that's cool. Thank you. I'd seen that before, but never knew what it meant.
So actually Alpine, I believe, is a tree. Alpine tree, no. What is Alpine? Yeah. It's a tree, it's a plant actually. And it is very, very small. So they have taken the name inspiration from this, which has nothing. It just has a flower. Nothing else, no leaves or anything. Yeah, cool, everyone. Any questions? This is a very important lesson, everyone. Okay. Dockerfile is perhaps the most important lesson. Okay. Writing Dockerfile is the most important step in any Dockerfile project. If you can't get Docker, forget Kubernetes. That is out of your reach. Okay. So learning Docker is totally most important part. We have buffer time. If you need any repeat of a lesson in the working days, please use that chance. Okay, in the last class bootcamp, we used 1 extra week to learn Docker. Okay, but do not skip this lesson at all. If you go to this day 1 here, you have these many assignments. Don't miss any assignment. If you can nail all these assignments, you're good. You're super good. Okay. If you can Dockerize this, you are almost 30-40% ready for most of the interviews, especially they're using containerized environment. If you are able to do this, then you are ready for Kubernetes. In fact, I have pitched this idea to the instructors that we should use that quiz thing that I have built the app, and we should test everyone's knowledge using quiz as well. Not only hands-on assessment, but quiz as well you will have. So you will have to probably score in quiz as well. So that is the idea we are discussing. If that goes through, then probably you will have to take a quiz on Docker as well. Then we will know how well you are learning. Do you support this idea or not?
Next cohort, please.
Yeah, it's the kind of thing where it's like, oh, that sounds great, but at the same time, well, it feels like we're putting them under the bus.
Okay.
Are we going to have any additional retros, by the way?
We are going to have, so the way how we generally do is like, after every assessment, you have a retro. This is what we used to do. Yeah. I think I know that we have missed a bit this time. Probably a bit more time discipline should be there, but yeah, I think we will have. All right, everyone. So this was the Dockerfile lesson. Okay. Now, should I continue? I know some of you have not done this hands-on with me. So I know that you will do it later though. Okay. So that's fine. Now the next step is pushing the beautiful image you built to the world. So anyone in the world can use the application you built. Okay. How would that work? So for that, okay, you have to tag your image with your username. So we built this dojo jump, right? 1.0. You will tag your username on this. So this is my username on Docker Hub. Okay. So I think the username should be here. Yeah. Oh no. Yeah. So this is my username. Okay. You can see these images I have built. Everyone has Docker Hub account, correct? If you have Docker this, okay? You can write Docker login. Okay, everyone, please log in into your system and type Docker login. You can see login succeeded. I am already logged in. Please type in your system. If you don't see this, you need to fix it. Everyone, please type this command, Docker login. If you do not see, then it will show you a pop-up. Please log in. Everyone logged in? Very good. Now you are ready to push your image. Okay. How do we do that? So let's push our first image. Let's go to Dojo Jump. Okay. We have used this command, okay? Docker build. Only thing is, you have to put your name, username. Your username could be different, everyone. You can see my username is visible here. Please find your username. Everyone, please find your username. Did everyone find the username?
Yes.
Very good. So what we will now be doing is, we will write, please go to the same directory, Dojo Jump, and write Docker build -t. Only thing is you will add your username. Code or not does not make a difference. Anyway, let's give it. Chandradevalia / I will give it, I already have an image with this name, so I will give it a different name. Bravo Dojo. And run it. You can see it is building the image. And if you write Docker images, you will see a new image with your username. Okay. Now you will write Docker push. Okay. You will give the complete image name followed by tag name. If you do this, it is now pushing your image to Docker Hub. You can give any name, it does not matter. Only the username should be correct. And that's it. It has pushed. If you refresh this, you will see the image I pushed just a second ago. Sounds good, everyone? Now the image you have created, that image has now gone online actually on Docker Hub. Anyone in the world can now look at your image and they just have to run this command, docker pull, and they can pull your image. Okay. So for example, I can show you. Let me remove all images. Let me remove this image. Let me remove this image. Docker images. Now thing is, you cannot directly remove, okay? Till you do not have the references removed. So what you will have to do probably is, I think we should be able to remove this one at least. Docker RMI. Unable to delete, image is being used by stop container. Oh, okay. So you cannot remove the image till the images are not deleted. So you'll have to first stop the images. So you have stopped the images. Let's remove these images as well. Now you can actually try to remove this. Docker RMI colon 0. Removed. Docker images. You can remove this one as well. Docker RMI. Okay, no door to jump anymore. Now you can directly use the image from the Docker Hub. Okay, this is just for your demo. You don't have to do. I was just showing you that your image has gone online. So you can use that image directly. Okay, how do we do that? So you can see here, this is how you can directly do. So you can write Docker, run -d in the background mode. I will write -itd. I will give dojo from hub -p. I can run it on port 8080 or my favorite port 876. Now you have to give the image name from here. So what is the image name? Username followed by image name. Okay. And what is the tags? You can see the tag is 1.0. So I'll give colon 1.0. You see, unable to find locally. See, it is now downloading the images. See, it has gotten the image. If I write docker ps, this is running. Now if I open port 9876, is running. Did everyone get this? I did not do anything new. Only thing is I pushed the image and I used my image. Yes, Troy.
Thanks. Sorry. The tag name, Dojo from Hub, where is that being utilized?
Oh, the name. If you see here, this is the name you get. Name of the running container. If you don't give it, it will give you a random name. That is the only difference. Yeah, for example, let's do that. So for example, let's run this one on probably 9000, and let's not give it a name. Okay, Docker PS. You see, hardcore Franklin, random name.
That's an awesome name.
Yeah, that's awesome. The way. And yeah, you have two Dojo jumper now running. One on port 9876, another one 9000. If you get tired of playing here, so one of my friend did this. He like opened two of these terminal two containers and playing simultaneously. Only possible with Docker.
So pulling images from Docker, how much security vulnerabilities is it?
Very good question. It is definitely a very high risk because you don't know what the guy has put. Let's say in my code, somewhere I write this, that grab all the file, zip the file and upload to my own S3 bucket. You will not know because that image is compact, compiled. You cannot see what is inside. There are ways, but you cannot generally see. So if you run this image blindly, you are vulnerable. Okay. So what you should do, you should always run the scans on the images. You should always use the images coming only from the trustworthy sources. Okay, you see the official images? These are the official images you can always use without any risk. Generally, these are the verified publishers. You can use these verified publishers. If you see a green tick, they are verified. But this guy, this user has no such tag. You see, no such tag. So if
Very shady. Very shady.
Yeah, so you can trust, but though you can trust my images.
That's what they all say.
Yeah, so yeah, but that is a very good question, Troy. Normally, organizations have their own Docker repository. People do not trust Docker Hub. So what you will have, there is a service in AWS, and I will show you. We will not be using it because it is a costly service. It is a paid service, not very costly, but it costs us some money. So this is called ECR, Elastic Container Registry. Okay, so this is called ECR, Elastic Container Registry. If you use this, your images will now go to this repository, in this repository, not in your Docker Hub registry. Okay, Docker Hub also has the option of private registries. Okay, so this user of the images you see, these are public images. There are also private images that you will not see here. Okay, but in Docker, in a free version, okay, you have only 500 MB of the space given for the Docker images storage. Okay, if you want to store more than that in private, you have to pay to Docker approximately $10 a month or something, but overall you have to pay. Otherwise, you can use AWS and you can use this one. Now, all the images which are in your registry, they are coming from your private source. So you will now trust these images within the organization. Troy?
At work, we have a container registry as part of our CI/CD. Can you speak, is this part of, does Docker Hub and the private registries that you're talking about, can it be streamed into CI/CD?
Yeah, they will be. And you should have probably a lesson coming on Docker CI/CD. Okay, that will probably cover that lesson.
There it is. Thanks.
All right. So that was all the lesson in today's class, everyone. We learned about what is Dockerfile. We learned about the Dockerfile syntax, different types of instructs that Dockerfile has. Okay, we learned from until maintainer run to copy, work dir and all. We learned a very basic one, hello world. Then we created an Nginx based application. Then we create a Flask based application. Then we use the optimized version of Flask based application. Then we learned how to push the image to Docker Hub. Then we use the image to run the container on our system without any image in the system already. Okay, so that was all the lesson today. Please let me know if you have any question.
I had a question. I'm looking at the restart command to just rerun the same container, but how do you attach a new image to it?
Oh, so for example, you have this one. Okay, you can write this one. Let's say you want to stop this. Okay, you can actually restart. This is a stop. You see, it is stopped. You cannot actually do anything except Docker. I think restart also works normally. Yeah, restart. You cannot attach the image because it is already built from an image. If you want to use different image, you have to actually run here. You cannot use restart command. Restart is only for the stopped containers. Okay, Tristan?
Gotcha. So there's no way to like remove an image from a container and then attach a new image, but save like the same name
Yes.
and port map and everything.
There is, right? So you have this. You stop both of this. Okay. I have stopped both of this. I will remove both of this. I have removed both of these. Right. There is nothing now. You go to your images, you run a different image that you want. Right. That's it. What did I do wrong? Oh, follow on 1.0.
Do we need that?
Yeah. Okay. Tristan, did you get it?
But that you deleted the containers?
I deleted the containers, but not the images.
Right. My question was there a way to keep the container because it's already got like a name you want and the port map, and then could you attach a new image to it? But that's
No,
not possible.
it's not possible. Yeah, not possible. Because see, what is container? It is a running instance of an image, right? It is the shadow. If you remove the object, where will the shadow go? Shadow. It's not like you can have the shadow. Okay, remove the object and bring a new object. Not possible.
Gotcha. Okay, yeah, the name container was definitely confusing me then.
Yeah.
Like a special box that only holds one specific thing.
100%. Yeah. Based on the whatever is the origin, it will just maintain that origin. Use that. You cannot change the origin because you got the name. And it's not such a big task to create a new image, right? New container. Yeah.
So is there ever a reason that you would remove an image from a container and not also just delete the container?
If you want to remove an image, you have to always remove the container first. For example, see, you have this running image, running container, right? If I directly go ahead and remove this Docker RMI image, it will not work. You see, unable to remove. It is using this reference, right? It's kind of, you're trying to delete the object while keeping the shadow. Not possible. I think shadow and object is probably not a good example, but it's like, like a copy. For example, you can say that, I don't know if you have a better example, but it's kind of you have the recipe and you have the food items, right? No, again, not a good example. But yeah, I think you got the idea, right? That this is the origin. You cannot remove the running container because it uses all the code and caches and layers and everything from the image actually. Image has the code. Container is only the runtime.
Can you go into detail about runtime architecture? So if an image is running, has a directory been made inside that is being run? So, for example, there was the work directory that we were creating. Is that inside the runtime as that? So the whole file structure, all of your application files, your peripheries, like image files and text files, is all of this represented at runtime?
100%, and very good question, Troy. Give me 1 minute. I'll be back, please.
Troy, you scared him off.
Oh,
Sorry. Okay, so Troy, to answer your question, how does the runtime look like? Let's see that. So you can write Docker exec minus IT. Let's give the container name. And let's go to /sh bash. There is no bash. /sh. Oh yeah, here we go. If you go to probably USR, yeah, bin Nginx, no, USR, not USR share, right? Yeah, share. Nginx. And if you go to HTML, here is your files. So even in the runtime, the file directory is maintained. This is the file actually which is being served. Okay.
can you show that path again? Oh,
Yeah, it is the same
user
path.
share engine.
Yeah, the favorite path. Yeah.
And you're currently on local.
No, I'm not in local.
You're in the image.
Yes. See, I'm the root user. Because I did Docker exec inside the container.
Yeah. Cool.
All right. Okay. So any other question, guys? Okay. So I see the message from James that learning has occurred. Cool. James, what was that about? Did you answer, like, was that in response of the quiz I proposed?
Oh, no, just the general class. A lot of light bulbs clicking today.
Okay. I thought that you are saying that, okay, no quiz is needed. Learning has occurred. Don't worry. Yeah, cool. Yeah. All right. So I think that was the lesson, everyone, for today. Okay. You have all the code and everything in GitHub, which I sent you already. And I believe not everyone has done the lessons. So please take the time and do the lessons. Okay. In afternoon, probably, if I will see if needed, I can probably take a class, or probably I have no other lesson for today. I have covered all the lesson for before noon and afternoon in this go itself. Okay. Otherwise, I was planning to do half of this in afternoon, but I did the complete stretch. Okay. And we are probably close to lunch. An hour almost away from lunchtime still.
No, breakfast. It's only 8:21 here. AM.
Okay, cool. And yeah, that's fine. Okay, so I think, yeah, in afternoon, no new lesson, everyone, but let's discuss the assignment for sure.
Thank you, Chandra.
Give me 1 minute and let's discuss the assignment, everyone. So this is the assignment that you have. So you have two assignments. First one should be very easy. You have this 2048 game. You have to build and push the image. Okay, the 2048. I'm not sure how many of you know this game, but this is a very popular game, 2048. Okay. And the assignment number 2 is you have this to-do list application. You have to Dockerize it. You have to write a Docker file and run the code now using Dockerfile. We have done the same assignment, very similar to this on Flask here. Okay. So probably you should be able to run. Okay. So this is assignment number 2, but this will take a bit of effort because you will have to create your network. Okay. But since you have learned network, I assume that you will be able to do. If you are not able to do, then I think I will send the code probably in afternoon in a while or something. Okay. But I will let all of you to struggle hard on this and get it working. Okay. All right. So these are the assignment for you today, everyone. Please get the assignment number 1 done, and assignment number 2, if needed, I will help you. All right. So that's all for today, everyone. Okay. Now we have stretched a lot. So let's go for probably 15 minutes break, 15 minutes break. Okay. And returning, you can start working on assignments. And let me open the breakout rooms. So you'll have the breakout rooms open. And Edwin, as always, is our super helpful to everyone. So he's here again today to help us. So yeah, use the opportunity to learn, everyone. Thank you, everyone.
Thanks, Chandra.